let me just jump straight to the topic, right? Let me see the topic that I'll be going to. Yeah, we have covered these though, so it's good, guys, to always attend whenever we host a session. It's good to always attend, because mostly those who don't attend, they face trouble or difficulties in such context, and they expect us to go through them again. And for sure, you can see that we don't have time. There's no enough time. So yeah. So if we come to the inequalities and the absolute values, we can see that most of the times we're given signs like this: greater or less. We are given, let me say this, you are given greater or less, greater or equals to, less or equals to. Sometimes, yeah, I think for now let's only discuss, since you guys are only looking at these only, right? So when it comes to the inequalities, these ones, they don't have that much of an effect. You see, right? They'll only have an effect mostly when we come to the absolute values. So we'll see how do we discuss them in the absolute values, because that's what you're gonna be talking about, such things as or and. You see, right? So we'll see when do we say or, when do we say and when it comes to the absolute values. So not to waste time, we're going to look at these examples that were given here. The first question, they say we should solve these 3x squared plus 10x less or equals to 5x plus 2. Then what you should do here, as long as this side, this is not saying less or equals to 0, we should try to take everything to the other side so that we can have a 0 this side. You see, right? So in other words, what I'm saying is that here you should always have a 0. So since you see here we're given 3x squared plus 10x, which is less or equals to 5x plus 2. So what we're going to do, we're going to take the 5 to the other side, which is this, and the 2 to the other side, which we get this. Then we simplify it, right? Then now we have less or equals to 0. You see right now. Now when you have a less or equals to 0 and have simplified the left-hand side function, you are going to factorize it. You see that you're going to factorize the function, and when you factorize the function, if it is factorizable, you're going to have two parts. Most of the times you only have two parts. These two parts are going to be divided into 2, then you combine them. For us to use the table method to check if this is going to be like this. Remember, in a number line, we have two options. Let's say we have this, right? And then here I get that x is equal to 1 over 3, and I get that x is equal to 2, right? We can have an option where these are going separate. Let's forget about the equal sign for now. We can have an option where these two are going separate, or we can have an option where these are going inwards. You see, right? They can go outwards and also inwards. So the table method will be there just for us to check or to confirm, do we go outwards or inwards, or are the values that satisfies these outwards or inwards? You see, right? So it means that after factorizing this, we're going to write our critical values. We're going to come and say the critical values are going to be, if I take this one and say this is 3x minus 1, which is less or equal to 0, this implies that 3x will be less or equal to, if I take 1 to the other side, this will be 1, and then my critical value will be, if I divide both sides by x, my critical value will be equal to 1 over x, right? Then again, if I take the x plus 2, which is equal to 0, let's say I just say here from here critical value, which this implies that x is equal to minus 2. You see, right? So now I need those critical values. Now I'm going to take those critical values. You need to make sure that these ones, when you put an equal sign, that are your critical values, right? I'm going to come on the table. I must have 3 sections here. So remember I said that these ones are going to be divided into two. Each critical value has its own equation. For this one, the equation is 3x minus 1 equals to 0. So I need this equation of 3x minus 1 here. And then the second one is x plus 2. I need the equation of x plus 2. Then I combine them. Is that right? Then our critical values, we gonna put them according to which one is small, which one is big. The minus 2 is smaller. I need the minus 2 first. I need 1 over 3. And then on these empty spaces, these are the values that are where it's x less than 2. Here it's x, which is between minus 2 and less than 1 over 3. And here it's x that is greater than 1 over 3. Then this one, we'll see to that. And then this is what, just that they left out these ones, right? This is what they should have written here. Here it's where x is less than 2. Here it's where x is between negative 2 and 1 over 3. And here it's where x is greater than 1 over 3. We are going to substitute those values there, right? So I'm going to check first. I'm going to come to this. Let me erase this. I'm going to come to this. You'll see when we come to do an exercise, right? We're going to do the same thing. I'm going to come here, substitute a value that is less than minus 2. I can substitute minus 3, right? When I substitute minus 3 here, I'm going to get minus 10. And I only focus on the negative, the sign. So this is negative. I put a negative there. When here, on the second equation again, let's say on the second equation, I substitute negative 3. I'm going to get a negative also. You said that negative 3 plus 2, that is negative 1. So now I come in between negative 2 and 1 over 3. I can put a 0 there. 0 is also between. I'm not going to put it there, but I'm going to substitute 0. You see right now. So when I come here and say 0 minus 1, I'm going to get minus 1. That's why we have a negative here. You see right. Remember now I've only done this. And then I come on this one. Remember also this one I've done it. I come on this one. If I put a 0 there on x, I'm going to get a positive 2. So that's a positive. Then I come here. Let's check the ones which are greater than 1 over 3. 2 is also greater than that, and 1 is also greater than 1 over 3. So we can choose 1. So if I plug a 1 here, I'm going to get a positive. That's how we have a positive there. Also, if I plug a 1 here, I'm going to get a positive number. That's how we have a positive here. Then we also need to plug our critical values. You see right now. So now when I plug minus 2 here, I'm going to get a negative. If I plug minus 2, I'm going to get minus 7. And that is a negative. Then I plug minus 2 here, I'm going to get a 0. You must write a 0. This is the only number that you write. The only things which you can write here, the only things which you can write, it's either a 0, a negative, or positive, or infinity, or minus infinity. These are the only things you can write in that table. You say right. So some tables will be forced to write an infinite based on if this thing has a denominator. You say right. So if I plug a negative 2, we know that we're going to get a 0. If I plug 1 over 3 here, 1 over 3 times 3 is going to give us a 1. 1 minus 1 is 0. So I plug a 0 there. Then here, if I plug 1 over 3 on this one, I'm going to get a positive number. Then we get this. You see right. We have plugged in all. If I multiply these two, negative times negative, I'm getting a positive. Negative times 0, I'm getting a 0. Negative times a positive, I get a negative. You see right. Then 0 times a positive, I get a 0. Positive times positive, I get a positive. And then now we need to check this. Let me see. Is someone saying, am I the only one who can't hear him? Can you guys hear me? Is there anyone who can hear me? If I think I had someone saying, am I the only one who can hear him? Who can see what says projecting? Let me check again. Let me try to project again, right? Problem when I ask questions, you guys don't answer, so I won't know if you really. Also, make sure that when you send something, turn on your mic, right? So, can you guys see my screen? Let me ask again, because I once asked and then everyone kept quiet. You can, right? All right. Thank you. If you can see it, then it's good. Now let's go back there. So if we can see this, right, we see that we are getting these values, right? We're getting these. So let me do this here. Let me erase them. I can try to do these separately in a table so we can see what do we get, right? We can see what do we get in this table, how to find this table. What matters the most is this table. This table is the one that matters the most. I hope we see that. So do we all agree that we can easily get this table? And let me do this. I think I said that. Let me not erase that. Remember, I said that these are the only things which can be written in the table, right? You can write the negative infinity, negative, 0, positive, or infinite. Right, let me do this. Let me just do this. Then we can write that question. What was the question? Let me see. Then I can do it. Maybe I can do it step by step. The question was saying, if we're given 3x squared. Okay, let me see. This is 3x squared plus 10x, which is less or equal to 5x plus 2. All right. Okay, I think it's this side. Yeah. So I was saying that if we can have this question, right? Let me just paste it here because I know that I think if I can do it while you are all watching step by step, it will be fine, right? So I said that what we're going to do here, we need to have a 0 here first, right? Before we can think of anything to do. Since we don't have a 0 this side, we're going to say this is 3x squared plus 10x minus 5x minus 2, which is less or equal to 0. So I need to take that to the other side. And here we're going to have 3x squared plus 5x minus 2, which is less or equal to 0. Then now we need to factorize this, right? For us to know how to factorize this, let's say you don't know how to factorize this, right? What you can do here, you can try to use quadratic equation for you to factorize this. So I can say that according to quadratic equation or the quadratic formula, we have that x will be equal to minus b plus or minus the root of b squared minus 4 ac all over 2a. Then we should let our a be equal to 3, our b be equal to 5, and our c being equal to minus 2. So this will be minus 5 plus or minus root of 5 squared minus 4 times 3 times minus 2 all over 2 times 3. Then this is minus 5 plus or minus root of 25. Then this is 12 times 2 is negative 24. That is positive 24 all over 6, right? We know that these two are going to give us 49, and root of 49, I'm sure it should give us something like a 7 if I'm not mistaken. You can try to check then and tell me what you get. All over 6. So this will be minus 5 plus 7 over 6, or minus 5 minus 7 over 6. And then this is 2 over 6, and 2 over 6 is 1 over 3. And this other side is minus 12 over 6, which this will be minus 2. Right, so we realize that our x values are x is equal to 1 over 3. Obviously, like you'll plug here with a calculator, right? So it will be simple for you. So I don't have a calculator next to me, so I'm just doing this step by step, right? And our x is minus 2 is equal to minus 2. So this means that our critical values in this case are going to be this. I need to I have this in this case. This one, we're going to multiply both sides by 3, right? We're going to have 3x, which is equals to 1. Then we take 1 to the other side. Always, when you get something like that, then this side, we're going to have 2 to be taken to the other side, which will become 2. Then these 2 are the values that we need. So it means that factorizing that, we're going to get 3x minus 1x plus 2. You see right now. So we'll need this. So let's go there and write 3x minus 1 plus times x plus 2. So let's go and write it. So I was just showing those who forgot how to factorize and all that you can still find your factors in this way. We just have to use a calculator. So you can just have your A, B, C in your mind, then you use the calculator. So this, now we have seen that this is going to give us 3x minus 1, then x plus 2, which is less or equals to 0. Then we're going to have our critical values. What we got on the calculator was our critical values, right? We had that x is equals to 1 over 3, or x is equals to minus 2. If we check this side, these are the critical values that we had. If we check here, these are the critical values that we had. Really here they're even using end on this one, right? So we can even use end. Let's say end there, which is reasonable. But in these ones, these signs, they don't matter the most. They only matter the most when we come to this one of absolute values. We'll discuss that. And then now we are having these critical values, right? Then we're going to use a table now. In the table, we need these sections. We have 2 functions here, right? So it means that I'll need the table to be like this. Then I'll draw 3 sections here. Yeah, then this is just an empty table, your empty row, this one. Then here I'm going to write 3x minus 1. Here I'm going to write x plus 2. Then here I'm going to combine them. All right, let me just copy that. Then I'll combine them there. Then I'm going to combine them here. And then here, I'll need to have a box where here it's x equals to, we start with the small one, which is minus 2, right? Then this one is x less than minus 2. Here it's x in between minus 2 and 1 over 3. And then here it's x being equals to 1 over 3. Then we also leave this empty part. Yeah, so if we check, remember, if we plug a number here, let me change the color. If we plug a number here that is less than negative 2, remember we can plug minus 3. When I plug minus 3, I'm going to get a negative. If I plug minus 3, it's also a negative. Negative times negative is what? It's a positive. You see, right? Then if I plug minus 2 here, I'm going to get also a negative. If I plug minus 2 here, I get a 0. Then 0 times negative, it's a 0. Then here, when I plug a number in between negative 2 and 1 over 3, I can say that I can take a 0. If I plug a 0 here, I'm going to get a negative. Here, I'm going to get a positive. Negative times a positive is a negative. And then here, on x equals 1 over 3, if I plug here, I'm going to get a 0. If I plug this side, I'm going to get a positive. This will give us a 0. 0 times a positive is a 0. You see, right? So now, if we go back, we realize that this is the exact thing which they had here. Which, if we check, is the same thing, right? Which we computed there. If you multiply these 2, you get a positive. Multiply these 2, you get a 0. Multiply this, you get a negative. Multiply this, you get a 0. And if you multiply this, you get a positive. So it shows that it is simple for us to get these values, right? If we check very well here, it is simple for us to get these values. So now the question that I can ask you is that what do you think that, since check here, this is saying that this is less or equals to 0. we just have to focus on the last part. Which part here do you think we're going to focus on? Are we going to focus on the positive part or the negative part? Let's focus on these ones here, the last row. Do you think we're going to create the formula, the sign that says this is less or equals to, right? Or are we going to focus on the positive or the negative part? Those who have practiced this and you know what to do, are we going to focus on the negative part or the positive part? Or you can just take a guess. Let's say you didn't know what you were doing. Which part were you going to focus on? Please make sure you don't comment there, because if you comment, maybe you can comment in the group. I think in the group, the messages, they can pop up here. Which part do you think we can focus on? The positive or the negative part? Are we going to focus on the positive or the negative part? Anyone? The negative, right? Because this is saying less, right? So it means that we are going to focus on, let me do this. It means that we are going to focus on this part, right? The negative part. So if we check, we're going to focus on this part, right? This one. So this is the negative. As long as our sign there said less than, it doesn't matter whether it's equals to or what, as long as it said less, right? We're going to focus on this. We'll focus on the last column. We're going to focus on the last part. And this one here, don't forget, this one is where x is greater than 1 over 3. Whenever I plug any number greater than 1 over 3, this one will remain a positive. This will also remain a positive. And positive times positive is a positive, right? So here, it shows that our solution here, the solution we'll focus on this, right? The solution will be that x lies, since this one has an equal sign there, since our sign has an equal sign, we're just going to take this, then we put the equal sign also. You see that? Remember, that one says this, but we're also going to put the equal sign since the equal sign is there, right? So we're going to focus on this negative part. So it means that our solution set lies within these two. So it is that if it was a number line, it will be that, let me erase this. If it was a number line, it will be that if we have -2, we have 1 over 3, it will be that this would lie within this solution set, given that this one is shaded, since there's an equal sign, alright? So I'm sure we see this. If it was a number line, it will be something like this. So since we were dealing with the table, this is what the solution will look like. So I think if we can, let me check here how the solution, how they decided on the solution. Yeah, they also decided the same way, right? Let's look at the second one, which is 3x minus 1 over x plus 2, which is greater or equals to 2, right? Let's look at this one. Then we'll see also how do we go with that. So now if we're given this, right, remember I said that this side should be a 0. Remember, since it's not a 0, we are going to make sure that we take this 2 to the other side. That was a minus. We're going to make sure that we take that 2 to the other side, as long as that is not a 0. So now we can have greater or equals to 0. So now before I can say a lot of things, right, what I can tell you is that we are going to focus on the solution set where we look at the positive side. You see, we're going to look at these positive ones, because here if we check here, we are given that this is greater. You see right now? So we are given that this is a greater sign. So it's greater or equals to, we just focus on the word greater. Is it greater or less? Since it's greater, we need to focus on the plus on the table. So we can try to simplify this until we get to the table, and then we see what our solution is. So this will be 3x minus 1 minus 2x plus 2. Right, I'm going to take this 2, this minus 2 multiplied by this, which is this, then I subtract it on 3x minus 1, for those who forgot. And then I divide by that whole set. If you feel like that one is a problem, you can just do this, cross multiply, then you'll get here. You say right now, then do that. And then this will be greater or equal to 0, right? And this will be 3x minus 1 minus 2x minus 2 all over x plus 2, which is greater or equal to 0. And then if we check this, this is going to be 3x minus 2x. This is x minus, then this is 2, that one is 4. This times this will be minus 4. So this will be minus 5 all over x plus 2, which is greater or equal to 0. I'm sure we see this. Now, when we get here, this is a very important part, right? When we get here, after getting to this final state, right, we need to specify here that our x is not equal to minus 2, because the moment it becomes equal to minus 2, this will be undefined. So we need to specify always when you're dealing with this kind of problems. You need to specify here. You say right that this is not equal to x minus 2. So now from here we can now take our critical values. Critical values. Nice thing about it is just we're gonna take both of them as our critical values. So I'm going to take x being equal to minus 2 as a critical value, and I take x being equal to 5 as a critical value. You say right. So you see that our format here, they're using and. So we'll say that we're gonna use and. Doesn't matter whether this is greater or less than, as long as we're not dealing with absolute values, this is always gonna remain and. So now, since we have the critical values, we can come to a table. Right, we can come to a table. Let me just draw the table somewhere here. We need, yeah, I think this is fine. Then what we know is that we'll need, what is that? X minus 5. And then we have x plus 2. Then if we don't multiply them here, we divide them. X minus 5 over x plus 2. According to that equation, says that we should divide them. And then, yeah, remember here I'm going to have between x minus 2 and 5, I think it's the x minus 2, which is less. So we'll put it here. Then here it will be values that are less than minus 2. And then here it's the values that are between this, and also the values that are equal to 5. And then here the values that are greater than 5. Yeah. So I think I can just put this table. So now let's substitute. If I substitute -3, negative, doesn't matter what negative it is, right? As long as it's less than 2, this will remain a negative. If I plug -3, this will remain a negative. Negative divided by negative will give us a what? A positive. You see, right? Now, when you come to this one, we plug -2, we'll get a negative. If we come to x plus 2, plug a negative, we get a 0. Anything divided by 0 gives us infinity. You see right now? And then we come, remember even here we say that x cannot be equal to -2 because it will give us infinity. And the table still confirms to us that indeed if x is equal to -2, it will give us infinity. So now if we take a number in between here, -3 and 5, we can take a 0 and plug here. I'm going to get a negative. If I plug a 0 here, I'll get a positive. Negative divided by a positive will be a negative. Yeah, this will be a negative. And then we come and plug a 5. If we plug a 5 here, we'll get a 0. If we plug a 5 here, we'll get a positive. 0 divided by a positive, it's a 0. And then here, if we plug any number greater than 5, we'll get a positive. Greater than 5 here, we get a positive. This divided by this is positive. Remember there our sign said this is greater. You see right now. So, or equals to. So it means that we're going to focus on these two. Remember, we checked the last row. So we're going to focus on those. So it means that x is less than minus 2. So remember, it's not equals to this. So we can't put in equal sign. You see right. And this side, we focus on this. And here we can say x greater than 5. But then this one goes with the sign. So we can just put the sign. Also, I'm sure we see this. Then I'll put O in between. So now we see, now we're no longer in critical values here. So we're going to put O. The answer will be this solution set, or the answer will be this solution set. I'm sure we see that. Or if you don't want to write it like this, this can also be interpreted like this. We can say this will be, let's say this is negative. Obviously this one is going to negative infinity and x is not included, so I'm going to put open brackets. Also, infinity and negative infinity, guys, can never be included, so we can never use a square bracket here. Or can be written like this. 5 is included, so I'll write square bracket up until infinity. The infinity won't be included. Then that can be the solution. I'm sure we'll see this. Then now let's see what we are told this side. Yeah, if we check, this is exactly what we did, right? If you check here also, they do specify here the condition that x cannot be equal to minus 2. Then they give us the critical values. Then after that, they put it in a table form. They also focus on this positive because now we're having greater, the sign. You see, right? And then the answer will be, this one we know that here it's where x is less than minus 2. So the answer will be that. And even though this says equals to, we can't put an equal sign there because x is not equal to minus 2. Then this side will put it, you see, right, where x is greater than 5. So the solution side is like that. So let's see the next example that we're given. On the next one, they say we should check the absolute values of 3x minus 4 greater than x plus 1. And what we should focus on is this side first. This is not 0. So it means that we can do something about it, right? But since we can't take it to the other side, even if we take it to the other side, it can help us in this case because all of this is inside the absolute values. So it means that we have to apply this method of taking two parts. Then we decide, do we put or do we put and in between? All right. Since we see here the sign, so I'm going to tell you this. If we can check on the second question, this one is, okay, not everything is inside the absolute values. Let's see if there were given exercise where, or an example where everything is inside the absolute values. It's not there. Okay, let's discuss the one that everything is inside the absolute values, right? When we have everything inside the absolute values, then we have greater than something. When you divide them, you are going to put or in between, or when you separate them, you are going to put or in between. Then when everything is inside the absolute values and this less than something, when you separate them, you are going to put and in between. All right, so we can go through that and try to discuss them. So let's look at this first example, then we'll come back to this. Or let me not erase them. So the example that we're given here, they say we must solve for x if the absolute values of 3x minus 4 is greater than x plus 1. Right? And then if we check, we have something here which is not 0. Right? So we're going to use this method to separate them. So what we can do here, we are going to take this inside. So there are two ways you can do this, right? that ways you can use this. There's actually the method which they use there. You can take this, right, as they did here. The sign doesn't change, it will remain the same. The sign also here, the sign remains the same. The only thing we should do, you negate this. The thing which you took out there, you see, put it here, put it there, you negate. Then from here, everything remains the same. There's that method. Also, there's this one where you can say this. We can try to use both, right? X minus 4 greater than x plus 1. Then when you come this side, you can also say 3x. This one does not change. You only change this. Then you negate this. You can also do that. So you can try to use any of the method, right? They will all lead you to the same solution. So this one, since this one is the same, let's try to compare this and see if we can get to this, right? So if you see here, we have 3x minus 4, which is less than, this will be minus x minus 1. If we take everything to the other side, we're going to have 3x minus 4 plus x plus 1, which is less than 0. And this will be, this will give us 4x minus 3 less than 0. So this will be 4x less than 3. This will imply that x is less than 3 over 4. You see, right? We got everything as it is. This is for people that they know that if you every time, remember when you divide by a negative, the inequality sign changes. You see, right? So you can try to apply any of the two. So we can use either this method or we use the other one, right? We can use any of the method. So let me see. Then let me just erase this one. We can use any of the method, right, to solve. I think I want to send these other questions here based on this. So I'll check them. Now let's go through this question. Remember, if I take this, remember this method, this one that which they use there, it says that this will remain the same. I'm just gonna put it here. We can just use this method for now, right? Then when I come to this one, I'm gonna put it as normal here, then this side negate it, put a negative there, multiplied by negative, right? And then since the sign is greater, I put O. Then this will be 3x. What they did here, they took the x to the other side, the 4 to the other side. Then this will be 3x minus x greater than 1 plus 4, which this will be 2x greater than 5. And if I divide both sides by 2, I'm going to get that x is greater than 5 over 2, right? Then this side, when I come this side, I'm going to first multiply by the negative here. Then I'll get negative 3x plus 4. Then I take this x to the other side, which will give us a negative x. Then I also take the 4 to the other side, gives us a negative 3. Then minus 3x minus x will give us minus 4x. Then I divide both sides by negative 4 over x. This sign will change to be facing the other side. Then this will be x less than 3 over 4. Right? So this is just a step-by-step procedure to take, right? So in this case, we can conclude that the solution is like this. There's no need for us to even use a table, right, in this case. So we can just conclude that the solution is in this manner. So now, if we come to the second example, this one, remember, not everything in this case is in absolute values. You see, right? Not everything is in absolute values. So that's why here they used O. But if everything was in absolute values and the sign was facing down, we're going to use AND. So now we're going to come and say, if I come to this one, let me see, we're going to come and check this side as usual. Remember this side we checked here, is this a 0 or not? And all the previous ones we checked, is this a 0 or not? So we're going to check, is this a 0 or not? If it's not 0, right? If it's not 0, just that here they used, I'm going to ignore this, right? I'll come to that method also. they used AI to solve this. Usually they were supposed to use this other method, which says that we must consider this one. Remember the absolute values from SMTH troop was 0. We learned that this, for I think it was page 8, we learned that x can become positive if x is greater or equal to 0, and also x can become negative if x is greater or equal to 0, right? And the solution set that we have here, we are given that x cannot be equal to 2. If x cannot be equal to 2, it means that x, the solution will be when x is less than 2, or when x is not, or actually let me say and, when x is greater than 2, right? And when x is greater than 2. You see, right? The solution set will be produced by that. That's why here they said if x is greater than 2. If we can go to the old guide before this one, I guess this one was edited, right? Let me just go to the old guide. I think this might be the old guide. Let me check. I think I even have these here on the old guide, right? Let me do this. Just that here. Let me see, right? I'll check if I have them here. Yeah. Yes, here's the thing. You see, from the old guide, you can see that the solution set was structured like that. It said if x is greater than 2, if x is less than 2. Reason being, we had focused on this part to know that x cannot be equal to 2. And if it cannot be equal to 2, it means that it should be less than 2, or not less than negative 2, less than 2. The solution can be less than 2, or the solution can be greater than 2. You see, right? That's what we know. So we would use cases for this, but we can just first look at the method that they use there, then we'll come back to this one. We'll come back to this guide. Let's just go back to that one. Then we talk about the one which they used here. So what they did here, right? Remember what I told you on the previous question? I said this on the previous question. Let me also erase this ones. On the previous question, I said that the method that I'm using here is the one that this remains the same. You see, right? This will remain the same. If you check here, it remains the same. It remains the same. Then they say, oh, right? Then since that remains the same, when we come here, we are going to do what? We are going to, actually, let me say this here. Actually, let me use these ones here. These ones will be clear. This remains the same. I can just use it here, right? When we come here, we are going to negate one of these. You see, right? That's what we did previously. Here, we say that this will remain the same. This is the method that they're using here. This remains the same. We are going to negate one of these. You see that we decided to negate this one. So it means that with us, we can just negate the right one always. But even if you would negate the one on the left, it's still fine. So even here, we do the same thing. This remains the same. This remains the same. We negate this one. You see right now. And then, since we already know the pattern now, we can now solve the left-hand side. The left-hand side, I said that if this is not a 2, remember we started by a question like, this was the second question like this. We said that if this is not a 2, we need to do what? If this is not a 0, not a 2. If this is not a 0, we need to take this 2 to the other side. You see, right? So this is what we did here. We took 2 to the other side. Then we multiply this 2. We're going to have this here. X minus 3 minus 2, x minus 2. This is x minus 3 minus 2x plus 4. X minus this give us minus x. Minus 3 plus 4 will give us a 1. You see, right? And then the denominator will remain like that. Once we get here, remember that this they use the AI, right? They forgot to specify that x cannot be equal to 2. Here, you remember we specify when we come somewhere here. they should have specified that x cannot be equals to 2, or they should have specified somewhere, since they decided to multiply to factor out the negative, they could have also expressed this somewhere here. X cannot be equals to 2. Also here, x cannot be equals to 2. So that's what you're going to add there. So this is our solution set, right? Then they say here, by the table method, we have the following solution. It's just that they didn't use the table method. You see that thing, the negate. Please explain the negate for right hand. Okay, let me also explain the right hand side. So we can take this to a table, since they didn't take it to a table, and we need to know how to define this x less than 1 or x greater than 2, right? So now for us to explain to the negated side, let me see the negated side. Let me see what they got. Yeah, so the negated side, remember this side we kept the x positive. Remember, the only thing that we need to negate here, just that I erase this, I'm going to write this. The only thing that we need to negate here, remember that the solution set can be this. And remember, not everything is inside absolute values, so we're not going to negate everything. You said we're just going to negate whatever that is inside the absolute values. This happens when x is greater or equal to 0. Here when x is less than 0. So here we will only negate x because it was the one inside the absolute values. So it's like we applied this condition. We say that for one, we're going to take the positive x. Then for the second one, we take the negative x. You say, right? And we just negate. That's why this 3, you see this not being plus 3. I know some might have maybe thought, why is that not plus 3? No, this is the reason. Because it's only the x that is inside the absolute values. You say, right? Then that's when here we ask ourselves, is this a 0? If not, we take 2 to the other side, which we have this. If we simplify, we're going to get this. Let's see. Let's simplify and say this is minus x minus 3 minus 2 times this, x minus 2. Then this will be minus x minus 3 minus 2x plus 4. Then minus x minus 2x will give us minus 3x. Then minus 3 plus 4 will give us a 1. That's how we have that. You say, right? And then from here, they also factored out the negative, right? Then we need to now specify. Remember, when you factor out the negative and divide both sides by negative, the sign changes. You see why the signs changed, right? So it's because they factor out the negative and then they divide both sides by that negative. Now it means that now our solution set will be focused on this. Great. So let's go ahead and write a table for this. So don't forget to also specify this condition where x is not equal to 2. So we're going to write the table. So for the table, we have x minus 1 and x over 2, right? So we can do this. Here now we have two different things, right? So we can say this. To make them fit, we can say this. We can start with the x minus 1 there. Then we come to the x minus 2. Is that right? Then here we have the 3x. Actually, let me do this. I can say this. Can even divide the table. Just that the table is for one thing, but we can try to be creative, right? We can do this. We can say from this one, let me erase here. We can just try. It's either we draw two tables or we draw one, then we combine them, right, as one table. So this can be, for this one, I'm gonna draw for this one. This is x minus 1, x minus 2. Then that divided by that will get this, x minus 2. Let's start with this one. So here, the critical values for this one, it's x equals to 1 and x equals to 2. So the one, x equals to 1 is the one which is less. So I'll put it here. This table won't fit. Let me try to draw it somewhere, right? I'll create a new page, then I'll draw the table because it won't fit here. Let me just try to draw it somewhere. So to draw it somewhere, I'm going to have this. I can even try to combine the two tables if we want to use a table. But using the cases, this would have been more simpler, right? So we have x minus 1, x minus 2, and then we combine them. Let me erase this line. And then we combine them, x minus 1 over x minus 2. Let's start with this side. Then remember, here it's where x is less than 1. Here we have a 1. Not exactly 1, but x equals to 1. Then here we have where x is between 1 and 2. Then here we have where x is equals to 2. Lastly, we have where x is greater than 2. Yeah, so if I plug here any number less than 1, let's say I plug a 0, I'm going to get a negative. So let me use a negative here. I'm going to get a negative. Then if here I plug also that number, I'm going to get a negative. I plug a 0. Negative divided by negative is positive. And then x equals to 1. I'm going to get a 0. Equals to 1. A negative 0, but this is 0. Then x in between 1 and 2, I can just take 1,5. If I plug 1,5, this one will be positive. 1,5 here, this will be negative. This will give us a negative. X equals to 2, this will be a positive. This is 0. Positive divided by 0, this will be infinite. A positive number, 3. Let's say I plug 3, I'll get a positive there. Plug 3 here, I'll get a positive. Positive divided by a positive will give us a positive. I'm sure we see this. Now, if we check, we can go back and check this. Remember our x minus 1 over x minus 2 was like this, was saying greater than 0. Such that x cannot be equal to 2. We agree to that, right? Now, since we have this case, we can now decide to say that the solution set of this one would be lying between these ones, because this is great. It's saying great. You see right now. So would lie the solution here of this first one. And then we can try to combine it with the other one, right? The other one says that we have 3x minus 1 over x minus 2. So we can even try to draw two tables for those. It's not a problem. We draw the second table. So when we draw the second table, since the second one says it was 3x, right? 3x minus 1 over x minus 2 is greater than 0. So it means that this is where x, the critical values are x over 3 and also x equals to 2, right? And remember here we need to specify that condition where x is not equal to 2. So now we are going to say that we're going to take where x is less than 1 over 3, because 1 over 3 is the smallest one, right? And where x is equal to 1 over 3, and where x is between 1 over 3 and between 2, and where x is equal to 2, and where x is greater than 2. And then let me just, I need 3 of these. Here it's where x, not x, is 3x minus 1, where we have 3x minus 1. Here we have x minus 2. Here we have 3x minus 1 over x minus 2. If I plug here a number that is less than 1 over 3, then here we're going to get a negative. You can check that with a calculator, right? Not really sure. Also here we're going to get a negative. Negative over negative is positive. So you can try to check that. Let me see. Now let me try to check it from this side. If I plug a number less than 1 over 3, that should be a 0. Yeah, if I plug a 0, I don't even need to check. If I plug a 0, I'm going to get a negative, right? Then if I plug 1 over 3, I'm going to get a 0. And if I plug 1 over 3, I'm going to get a negative. Then this will be a 0. Then this side, if I plug in a value in between 1 over 3 and this, let's say I plug a 1, I'm going to get a positive. Here I plug a 1, a negative. So this will be a negative. Then if I plug a 2, that will be 6 minus 1 is positive. Plug a 2 here, it's a 0. This will be infinity. Positive divided by 0 is infinity. Plug a number that is greater, it's positive. Also this will be positive. Divided by this is positive. So it means that the solution set of this one would lie here. Alright? So it means that this one would give us the solution where x is less than 1 over 3. This one where x is greater than 2. Now we got two different solutions. This one here, it was where x is less than 1. Here it's where x is greater than 2. Now we need to draw these two. Now we need to combine them and check which one. But on the right hand side, which we see that here we have one thing, which is x greater than 2. Oh, now let's decide on the left hand side. On the left hand side, we can draw a number line, right? We check. We are comparing these two. We have 1 over 3. We have 1. And one of the solution, the first one say that where x is less than 1 over, where x is less than 1. Then the second one says where x is less than 1 over 3. I'm sure we see this. So now we need to decide between these two. Which one is going to be the main character, right? Or something like that. So we're gonna have to also plug here numbers in between and check if they do agree with this. We're gonna plug here, we'll plug here, we'll plug here. So we'll need to plug on the, let's take the original equation first. This was the absolute value of x less than 3 over x minus 2. Was that less or, let me see. Yeah, less than 2. Let's say here I plug a number that is in between 1 over 3 and 1. What number do you think we can plug? Let's say we plug 1 over 2, right? Do you think that when we plug 1 over 2 here, are we going to get a number that is less than 2? Let's decide, guys. Let's say I plug 1 over 2 minus 3. This will be 1 minus 6 over 2, and that is minus 5 over 2 on the numerator. And then here if I plug 1 over 2. Can someone with a calculator do that? Someone with a calculator can try to find these as fast as possible. If you can, let's just do this. 2 over to this and this will cancel. We'll have 5 over 3. And 5 over 3, we know that 3 goes once here. So indeed, if I plug a number in between, this is correct. It's less than 2. You say right. Let's plug a number that is greater than 1. Let's say we plug, greater than 1 can be 1 over, or we can even plug 2. Let's plug 2 for this to be simple, right? To solve. Let's say I plug 2. If I plug 2 here, I'm going to get, let's say also here I plug a 2. Now I can't plug a 2, let me plug a 3. Because if I plug a 2, this will be a problem. Let's plug not a 3 actually. Let's say we can plug 1,5. Yeah, it's fine. We can just plug 1,5. It will be fine. Well, let me do this. 1 over 2. No, is this? No, not 1 over 2. No. 1,5 is 3 over 2. 3 over 2 minus 3, which this will be equals to 3 minus 6 over 2. This is minus 4 over 2. This is minus 2, right? This one gives us minus 2. You can try to check that with the calculator if it's minus 2, right? You can see that I'm not using a calculator. So, also here we plug 3 over 2. It should be minus 2. This will be 3 minus 4 over 2. And this will be minus 1 over 2. So if I take this divided by minus 1 over 2, it means that when I multiply them, I'm going to change that to minus 2. And this will give us what? A 4. Is a 4 less than 2? No. So this won't satisfy the side, right? Then we check here. Obviously here, if I plug any number less, it will always satisfy because the one here was satisfying, right? So it means that we are going to, it's what? It's minus what? Minus 3. Which one is minus 3 over 2? Which one is minus 3 over 2? Oh, you mean that one? Oh, 3 minus, oh, this one is minus 3 over 2, ne? Okay, I think I get that. And then here, this is going to cancel this. So it means that we're going to get what? 3, right? But still, 3 is still greater than 2. So this does not satisfy. You see, right? So it means that we are not going to include it. So it means that we're going to take this one, right, and everything below it, because that one was satisfied. So it means that when we come here, we're going to say all x less than 1. So that will be the solution set. We can check what they decide the solution was. Yeah, you see, right? They say by the table method, we have the following solution, which is x less than 1 or x greater than 2. But with the cases, guys, let's go to the other method of the cases. Maybe that one can be better, right, for understanding. Let's go to the other one of cases and see. Also, the other one can be better, but then they can all generate different solutions. So let's see this one, what this one would generate. So this one says that when we come here, remember I said that if I think I erased those things. So remember I said that here, when you see this, this one, what they did on the method, they tried to make sure that everything, we only leave the things which have an absolute value so that we can use this method. Remember I said that when you have less than and you want to separate this, you're going to use and. If everything is inside the absolute values here, right? And I said that if it's greater and there's absolute value here, if you want to separate it, you lose all. You see, right? Now let's check. This one is great. You see, you use all. So let's discuss this method and see how will the solutions differ. So let's see. Now, the question was given to us like this. Like the absolute value of x minus 3 over x minus 2, which is less than 2. And then we were told that we should solve here, right? And check which set is correct for this solutions or the equation. And then for us to find the solution set, remember that we know that x cannot be equals to 2. And if x cannot be equals to 2, as long as the absolute value is on one, let's say it's saturated on a certain x value. Let's say not everything is inside x. Just like here, it's only the x that is been there. So we're going to discuss here. Is this equals to not? It's not, right? So this will know that it will be possible if we have these two parts. This or this. So we have two cases. We have case number 1 where x is greater than 2, case number 2 where x is less than 2. So for us to decide where x is greater than 2, we're going to come and say that if x is greater than 2, we're going to solve this. First, we must make sure that the x is it's alone. You say right now, the x should be alone. Then we're going to say, if we want this x to be alone, I'll multiply both sides by x minus 2, which I'm going to have this. Then I take 3 to the other side. Then I simplify, I get 2x minus 1. Then now I get the absolute value of x less than this. Since everything this side is inside the absolute values and the sign is less, I'm going to now use the properties. And remember, we have these properties of absolute values. That is the absolute value of, let's say the absolute value of x less than 1 will imply that this is minus 1, x1. We did this in formal definition. Remember, right, in SMTH, you did this in formal definition. So now, when you come here, you can try to separate this. This one, this side it will have a negative, this side it will have a positive, right? Then you try to simplify this side. Then now you need to find for x. You're going to divide them like this. Since we know that the sign was less here, we're going to divide them and say that this will be less than x and x will be less than that. Then we'll just use and, right? And then we try to solve both sides. And when we solve both sides, we find this. Remember, when you divide by negative, the sign will change. This inequality sign will change to be greater now. And then we'll decide which one stands out, right? But now they say the x greater than 1. We'll come back to that. We can also use a table method. So we'll see that. Now, we come on case 2. We check where x is less than 2. So, when x is less than 2, we are going to change the sign to greater. You see right now. So it's like I did this. It's like I said, remember the original one was like this. So I think I need to write, I think they should have written these 2 cases. So since I have 2 cases here, guys, I'm going to write this like this. Let me say gray, it was less than 2 here. Initially, yeah. It was less than 2. Remember I said that if you want to solve this, you can use this method of saying, I'm going to take this first. You see right? I say less than 2. Since this sign is less, I'm going to say and. Then I take the other one. Now I'm going to negate this. Let's say I don't want to change this absolute value, right? I'm going to negate this. Let's say I don't want to change it. Then this will still be less than 2. If I divide both sides, I'm going to get absolute value of x minus 3 over x. This was minus 2, which this will be greater than 2. You see, when they say they're taking x greater than 2, that's why they x less than 2, they pick this one. You see right, we were multiplying by negative. You see right. Then if you want to understand, for better understanding, we can look at this equation. We can derive it from this. We remember that this was positive x if x is greater or equal to 0, right? And this was negative x when this was less than 0. Then in now, instead of less than or greater than 0, when we come to this one, we are now discussing it. Remember, now it's like I'm replacing this by this one, right? So I'm going to write it here. This will be positive. Remember, this will remain the same if x is greater than 2. Obviously, it can be equals to 2. So I'll just keep out that one of equals to 2. Of equal. I'll just take out that equal, right? And this will be negated. It will have a negative, right? If x is less than 2. That's why for the first case of greater than 2, we use this one. We say this will be like this. And then on the one of less than 2, we keep it like this. So we now see we have to multiply by negative for the one where x is less. So if we go back here, we end also, or maybe let me just try to take them from here. So let's check it from here. Like, let's take it from here and say that if x is greater than 2, this will remain the same. Remember, the original equation was like this. It was saying this is less than 2. So you're just going to solve it like this. You need to make sure that the absolute value of x is alone. So I'll divide both sides by x minus 2. Then I try to solve this like this. And then this will be 2x minus 1. You see, right? Then we stop here for this one. And we say that if now x is, now it should be less. For the one where x is less than 2, we're now going to multiply this by negative. You see, right? And this will still be less than 2. That's why they decided to say that if I divide both sides by negative, I'm going to get this. Which this will be greater than. This will be minus 2. This should have been minus 2. Now I see they also made a mistake here. They should have said this is minus 2, right? They should have said this is minus 2. Just like they use AI for these things, so sometimes they can make a mistake of a sign and so on. I'm sure you saw with the other one when they were writing the guide, then they mistakenly removed this and it used another method, right? So this would be, if we check carefully now, we need to make sure that we make x subject the formula, this one, right? The absolute value of x. So I'm going to multiply both sides by this, x minus 2. This implies that the absolute value of x is greater than minus 2x plus 4 plus 3. It means that this one should have been like this. Alright, so now when we come here, if we check, this was what was great. If it's greater, when we separate this, we're going to use or, right? If it's less, when we separate this, we're going to use and. So if we check here, this is great, this is less, we're going to use and. So it means that separating this, we're going to say that first, before I separate them, let me start by applying this law of absolute values. And then I'll separate them from here. This means that this would be, let me write it from here so I can have a lot of space. Minus 2x minus 1 less than x. Since it's less, I'm going to say and x less than 2x minus 1. Then I start solving for this, obviously. And then this will be, then the x goes that side, then this will become 3x. Okay, let me write it as it is, so we don't miss the sign, right? 3x, this implies that 1 over 3 is less than x. Then this side we get x. Take this to the other side. This will be minus x less than minus 1. And if I divide both sides by this, I'm going to get that x is greater than 1. Now the sign will change. If we check, that's what we got there. I'm sure you see this. Alright, that's what we got. Now, if we come to the other one, this one of O, we realize that now this is no longer this. Remember, this one cannot be written in this solution set. We don't have a property for this one, right? So we need to use that method we were using before here, which I was showing you that if you want to divide this into two things, you're going to keep this one the same. You see, right? Then since it's greater, we're going to use O. I also keep it the same this side. Then this will be positive, this will be negative. I only negate that. You see, right? Then this will be, take this x to the other side, it becomes 3x greater than 7. Or this would be, if I take this to the other side, it will become x greater than 7. And this would be, yeah, like that. And then this would be 3x, not 3x, that means the same here. This would be x greater than 7 over 3. You said it. If we were using this method, I'm sure we say this. And here, if you can check here, most of the things, they would be not be that difficult, right? If we check this, we can draw a number line and see why the solution side is like that. If we check here, we have 1, we have 7, we can have 7, we can have 1, 7 over 3, 3 goes 2 times here, or the 7 over 3 is somewhere here. We can even try to draw these things down in the same number line, right? Then 1 over 3 here. Yeah. Then we try to check which one works, which one doesn't. If we put them down together here, it means that we're going to use the original one, which is this. You said it. If we put them together, using a number line would be simple. So we would say, if I plug now, let's say I plug any number less than 1 over 3, let's say it's 0. Here I would get a positive, which is less than 2, so which is correct. And let me say, I would get 3 over 2, which is less than 2 there, which this would be correct. Then if here I plug any number between 1 over 3 and 1 over 5, let's plug 1 over 2 here, right? Is it 1 over 2? Let me see. Between 1 over 2 and 1 over 3, which one is big? Obviously it's 1 over 2, right? Yeah, if I plug 1 over 2 here. So if I plug 1 over 2, can those with the calculator check what do we get again here if we plug 1 over 2? Okay, to simplify this, I would multiply here by a 2, multiply here by a 2. This would cancel this. This would cancel this. If it comes here, it's going to give us minus 6. Here, minus 4. So we're going to get something like 4 goes how many times to the third? 3 over 2. And 3 over 2 is less than 2. Yeah. And then if we plug, what else can we plug? 1 over, yeah, but it's fine, we can just pick one number. Then 3 over 2 is still less than 2, and this would work. That's why there on the other solution set we had where x can be less than 1, but we don't have x less than 1 here, we remember, right? So that won't count here. So we check it from this side where x is greater than, and also it's between these two. We know that this goes 2 times. That means that we can plug 2 here. So if I plug 2 there, 2 minus 3, yeah, I can't plug 2 because 2 is not, it's in the denominator. I can plug 2. Probably I don't have a calculator. Is anyone who's willing to show this for us, or you can check them? Because I don't have a calculator, and I think plugging them one by one would be difficult. But regardless of that, right? We can check why did they decide to, let's say when they applied that negative here, why did they decide to just say greater than 2, right? And not negate this? Because in all methods we see that we should negate that, right? So it means that we can decide to check which method can we use. So I think now I understand why they also wrote the second guide and changed this. They decided not to use this method because they saw that if they use this method, they're going to have some contradiction here. So you can decide on your own which method can I use. It means that if you use this one, you also need to consult with your lecturer to say, wasn't this, according to the theory which I shared with you, wasn't this supposed to be a negative? And if not, it means that you have to adapt to a new method, right? To say that if I'm not going to use that, it means that whenever I check the condition where x is less than 2, I'm going to have to say this is greater than 2. I'm not sure if we can all understand that. And if that's the case, it means that we can adapt to the new method, right? So you can come across many methods for this one. You can have many methods, but it's up to you which one to choose. So this one, you see, it gave us a different solution. 1 over 3 and 1 here. You see, this one says that they decided to go with x greater than 1 and also x less than 1 over 3. But the other method gave us, and we confirmed that with a table, gave us x less than 1, x greater than 2. while we're dealing with the same solution set. You say, right? So you'll decide, guys, which method to use on that. So I think, yeah, what I can do now, right now, I can give you a hint on how to solve these ones here. Now, remember, with this one, I say that if we're given, let's look at the one which I highlighted, right? I think it's letter C. Yeah, I think this one is letter C. If we check this one, we're given that the absolute value of 5x minus 1 is less or equals to 2x minus 3. So I want you to try to solve this, right? Or I can give you first a hint to say that, remember that there are two methods we can use. There's one that says that we can negate this. We keep this one the same, this side. Or let's start with the one where it says we don't negate, we keep it positive, right? X minus 3. Since this is less or equals to, that is saying it's less, we're going to say and. Now we negate this. Right? You can do this. You can try to find this. Now, in other words, what this is telling us, it's saying that we must try to find the intersection here, right, between the two, because we're using and. So let's see what we can get. We can say here this will be 5x, we take 2 to the other side, minus 2x less or equals to minus 3 plus 1. This will be 3x less or equals to minus 2. And this will be x less than 3 over minus 2. And let's see this side. We take this to the other side, right? Or let's leave the minus 3 this side. And this one will be minus 7x less than or equals to, if we take 1 to the other side, this will be minus 4. Then x will be less or equals to, oh, this one will be great because of the negative. If I divide both sides by negative, 4 over 7. If we check here, we got two things. We got that x is less or equals to 3 over minus 2. Let me check this. If I take 2x to the other side, I'm going to get a negative 2. Then 5 minus, this will give us that, which this is correct. Yeah, this is correct. This is minus 2. This is 3x. Then divide by that, I get this. So we realize that we got this, right? This is what we got for this question for the time being. Now, we can try to write them in a number line to check this. We can check, this is saying, I think the one which is small is this one, and the bigger one is this one. Now it's saying and, right? It's saying that x should be less or equal to, it's saying that x should be this. So we want to check if it's true. And this is saying x should be this. Alright, so we can now check this. How the question is, how can we check this? So we're going to try to find if these two intersect. According to and, these two should intersect. So if these are going in the opposite directions, the question is, do they intersect? I think this is a different type of question. They're very rare to find these ones. Who can tell me, are these two, let's say this one is going that side and this one is going that side, are they intersecting? Guys, are these two intersecting? Is it not minus 2 over 3? Is it minus 2 over 3? Oh yeah, it's minus 2 over 3. Yeah, I didn't see when I wrote that. Minus 2 over 3. Yeah, we'll just have to change this one only. So are they intersecting, guys? Are these two intersecting? You can tell me, guys, are these two intersecting? Anyone you can give it a guess. Are they intersecting? No, right? So it means that Since we see that they're not intersecting, then what will be our solution here? Who can tell me what will be the solution? The solution will be what? Do you remember what is called an empty set? Do you remember what is called an empty set? So it's possible to come across the question. I think I sent this other question. This one, the solution would be an empty set. They don't intersect, right? Let me check this there in the group. I think let me check this. I once sent these other questions here. There's also this other one here. I think it does not. Okay, let me try. Maybe let me see if I have that app thing for photomath. Let me try to search this question. I think the question was saying that we have it was the absolute value, right? Let me see. We have where can I find the absolute value? It was the absolute value of 5x minus 1, which was less or equals to, I think it was 2x minus 3. You see, right? The solution set for this would be, remember there we got what? We got x less or equals to negative 2 over 3, and also x greater or equals to 4 over 7. You see, right? We realize that this is going this side, and also they also check the 1 over 5, which according to our method we can get 1 over 5, right? We are only getting we're only getting this one. So we checked this 1 over 5 is in between them. So we checked 4 over 7, and also we checked for where's the other one? Let me check. Yeah, we checked negative 2 over 3. We realize that there's no intersection for this. So the solution will be an empty set. Do you guys see this? So the question was saying, yeah, this. I think you can try to do this one. I think the solution set can be similar. I think I forgot if it's number 2 or what, but number 2 looks like the solution set can be somehow like that. You can try number 2. You'll see that the solution set will be some sort of like an empty set. So it's possible to get an empty set, but not always, right? In most cases, it's when you're having this one of less or equals to, where you're having and, but then these things are not intersecting. You see, right? So you can try that. Do we get it? You can try to check that. The question is, do we get an empty set? And we really check that, and we realize that, yeah, we're getting an empty set. All right. So we realize that we're getting an empty set. So are you guys cool with this solution? Once we saw we even used photomath, they also said that it's an empty set. So what I'm gonna do, I'm just gonna upload this, right? If you feel like you didn't understand that, you can try to look at it. Then you also ask. You can. I prefer that you send your solutions, your things in the guide, right? You're in the group when you want to ask, so that maybe others can attend to them if they know the solution, or also I can also attend to them. So, cause I think it's simple that way. Cause if all of you text inbox, I won't be able to reply all of you, cause you are too many there. So you can try to do this one. So I won't do this one for you. It's simple. This one also I believe it's simple because it doesn't have any inequalities. The only ones which are troubling can be these. With this one, you need to decide with which method are you going with. You're going with the method of the new guide or the old guide. It's up to you. But the one of the new guide, you can see it's short. You can also check there again of how did we do it, because we were able to arrive to the solution. Then this one, it's also simple. You can do it this way. You see where your solution will be. So yeah, I think it will be like that. I think we can just stop here, guys, for now, and then you'll ask questions based on what you didn't understand.